Hi everyone, lesson 3.4, solving two-step and multi-step inequalities. For this first slide, you do need to write this down, but this is just some information of what we need to think of when we're solving multi-step inequalities. So multi-step inequalities that contain more than one operation require more than one step to solve. When solving multi-step inequalities, use inverse operations to undo the operations. Sometimes you might need to use orders of operations, combining like terms, or using the distributive property when solving. Here we're going to get right into some examples. So for these examples, we're going to solve the multi-step inequalities and then we're going to graph the solution. For our first example here, we have 2 minus negative 10, which is greater than negative 4t. Remember, when you have two negatives next to each other like that, a negative and a negative become a positive. So on the left side, we will have 2 plus 10, which is greater than negative 4t. Let's combine 2 plus 10, which is going to give me 12 on the left, is greater than negative 4t. When solving this inequality, we want to get t all by itself on the right side. So we're going to divide by negative 4 on the right, divide by negative 4 on the left. Remember, when we're dividing by negative values, we do need to flip that inequality sign, so now it's going to be the less than sign. 12 divided by negative 4, positive divided by negative, is going to give me a negative answer, negative 3. Is less than t. Notice I showed all my work to solve that multi-step inequality and I got my final answer. So now we have to graph. I have my number line, 0, negative 1, negative 2. So if negative 3 is less than t, I'm going to have an open circle at negative 3. T is greater than negative 3, so I'm going to shade to the right. And that'll be my final answer for example number 1. Let's go on to example number 2. Here we have negative 4 inside the parentheses 2 minus x, which is less than or equal to 8. For this example, we need to use the distributive property. Remember the distributive property, you would multiply negative 4 times 2, which is going to give me negative 8. Negative 4 times negative 1x is going to give me a positive 4x. So on the left side, I have negative 8 plus 4x, which is less than or equal to 8. We're solving to get x all by itself on the left side, so I first need to add 8 to both sides. So I have 4x, which is less than or equal to 16. I now need to get x by itself, so I divide 4. We're dividing by positive here, so we'll leave it with the less than or equal to sign. So I have x is less than or equal to 4. So I've shown my work, I've solved for the inequality, now I need to graph. When I graph it, here's my number line. X is less than or equal to 4, so I'm going to have a shaded in circle at 4. If my variable is less than or equal to 4, less than, I'm going to shade left. And that'll be my graph. Example number 3, again we're solving and graphing the solutions. Here we have 2m plus 7 parenthesis m minus 1 end parenthesis, which is greater than or equal to 26. I am going to distribute this 7, multiply it by m. 7 times m gives me 7m. 7 times negative 1 gives me a negative 7. So on the left I have 2m plus 7m minus 7, which is greater than or equal to 26. Let's now combine like terms, how we have an m and m, 2m, 7m. That's going to become my 9m minus 7 is greater than or equal to 26. We're solving for the inequality, solving for m, so we need to get m by itself. We're going to add 7 to the left, add 7 to the right. So I have 9m is greater than or equal to 33. I'm going to divide 9 to each side. So m is going to be greater than or equal to, we're going to get a decimal of 3.6 repeating. So now we need to graph this. On my number line, I have 3. I'll do 3.5, 4, and 4.5. 3.6 repeating is about right here. So now, if m is greater than or equal to 3.6 repeating, I'm going to have a shaded in circle at 3.6 repeating. If m is greater than or equal to that, I'm going to shade to the right. So here is my answer that I saw for the inequality, and here is my graph. Our fourth example, we have 3p plus 2, which is less than or equal to 7p minus 5. Now for this one, notice we have p's on each side of the inequality sign, and we also have numbers that stand alone on each side of the inequality. So what I'm going to do is make it so that I have all the p's on one side and the numbers that stand alone on the other side. So what I'm actually going to do here is I'm going to bring the values, this 5, over to join the 2. So I'm going to first add 5. Whoops. I'll first add 5 to both sides. So I have 3p plus 7 is less than or equal to 7p. Now I want to subtract 3p to each side so that I combine the p's together like terms. So what I'm left with is 7 is less than or equal to 7p minus 3p is going to give me 4p. So I have 7 is less than or equal to 4p. I want to get p by itself, so I'm going to divide 4 to each side. 7 divided by 4 is going to give me a decimal again, which is 1.75, which is less than or equal to p. Let's graph this. Here is my number line. 0, 1, 1.5, 2. 1.75 is going to be closer to 2 here, so I'm going to have a shaded circle at 1.75. 1.75 is less than or equal to p, or p is greater than or equal to 1.75, so I'm going to shade everything to the right. And that is my graph. Last example, it is giving you a word problem here that we want you to write as an inequality, and then we want you to solve the inequality and graph the solution. So here we have 6 is less than or equal to the sum of 4 and negative 2x. So 6 is less than or equal is the sign, to the sum. Sum means we're adding the sum of 4 and negative 2x. So 6 is less than or equal to the sum of 4 and 2x. So that's how we would write out that inequality. So now what I need to do, I do want to get that x all by itself on the right side. So I'm going to subtract 4 first to each side. 6 minus 4 is going to give me 2, which is less than or equal to a negative 2x. I'll divide each side by negative 2. Here we're dividing by a negative value, so we do need to flip that inequality sign to be greater than or equal to. So we have negative 1 is greater than or equal to x. So this is what I solve for. Now I need to graph. Negative 1 is greater than or equal to x. Since it's greater than or equal to, it's going to be a shaded in circle. So if x is less than or equal to negative 1, I'm shading everything to the left. Everything to the left is representing x. So I have wrote out my inequality. I have solved for it by showing my work. I expect you to show your work. And now I have graphed it. So these are our notes for 3.4, and then we will do bookwork problems in class tomorrow.